present to you the fizzy lava lamp. The question is, what happens when vinegar and baking soda meet and react inside a bottle of oil? So we predict that the vinegar will sink to the bottom because it's heavier than the oil and create gas bubbles when it touches the baking soda and making a lava lamp work. The things you need is a tall clear glass and some oil and baking soda and vinegar, food coloring, and one small spoon. So basically, this is the finished lava lamp model, and the thing in the middle is the oil, which is like the middle part, and then the white thing on the bottom is the baking soda, which sinks down because it was heavier than the oil and stays down. And then when we added the food colored vinegar from when we dropped that, it sank down because it was heavier than the oil, because it was hydrophilic. And then it met the baking soda, who stays in the bottom waiting for them. And then together they created a carbon dioxide gas, the CO2 gas. And then it's a gas, so it's lighter than the oil, so it floated back up. And then when it reached the top, the CO2 gas escaped in the air, and then there was only vinegar again. So the vinegar went back down and then met the baking soda, and they created the CO2 gas, and it went back up, and the CO2 gas disappeared, and then the vinegar went back down. And then it just kept repeating until there was no vinegar or baking soda left. And then that took like 10 to 20 minutes. According to that experiment, we learned a few things like polarity. So vinegar and food coloring are hydrophilic, which means they love water. But then the oil is hydrophobic, which means the opposite of love water, which means fearing water. So they do not go along well, so they don't mix. The vinegar, which is the acid, and then baking soda, the base, when they meet together, they perform a carbon dioxide gas, also called CO2 gas, that floats back up and then pops and goes down. Our hypothesis was correct. We successfully created a working lava lamp model using simple household items. Any questions? Yes?
So how does all of them doesn't mix together?
Because the oil is hydrophobic, which means it fears water, so it doesn't like water. But then every other ones are hydrophilic, which means they like water.
Why did you make the CO2 gas? How did you make the CO2 gas?
The CO2 gas appears when vinegar and baking soda meets. So like when they touch, a CO2 gas will appear.
But is baking soda a little bit going up or
No,
staying
the
down?
baking soda stays down. It's the vinegar that goes up.
No, we don't need the baking soda.
No, the baking soda is needed to make the CO2 gas.
But so far away.
No, the vinegar, if something's heavy, it drops down, right?
But CO2 gas isn't heavy.
No, the CO2 gas isn't heavy. The vinegar is heavy.
Yeah, the vinegar drops and then this makes it bounce up.
Yeah, the baking soda helps it go back up.
How does it help it go back up?
Because when baking soda and vinegar meet, this is the baking soda, and then this is the vinegar. Vinegar floats down, and then it touches, and then it makes a CO2 gas, and that CO2 gas floats back up.
Then, does that mean this whole thing will turn into CO2 gas after all?
No, the CO2 gas will, disappear when it goes to the top.
Oh, then... But how is it right now not disappearing?
Because it takes a little time.
How minutes?
Until it all disappears?
Mm-hmm.
It depends on how much baking soda and vinegar you use, but maybe about 10 to 20 minutes.
Bye-bye!
Bye-bye.
So yeah, and these are the gases that when they meet, they perform like a CO2 gas bubble, and then later the pump dissolves, and then it goes into the CO2 gas goes. It goes down to